Hello. So if you looked at the previous video of this, I went ahead and did this one with a little assistance from my friend Mr. Hyde. We did x to the fourth plus 3x cubed minus 5x plus 4, and we divided that by x plus 1, and our result was x cubed plus 2x squared minus 2x minus 3 plus 7 over x plus 1. So, two things here. One, I got rid of Mr. Hyde, all right? He's not going to be an issue with this one. Two, we're going to go ahead and use synthetic division on this and see if we can do the same problem a different way. All right, now synthetic division is kind of cool. First of all, I'm going to take my divisor of x plus 1. Oh, by the way, I recommend synthetic division if the divisor is a binomial, right, with two terms, and the degree is a 1. So the power here is a 1. Yeah, it's possible to do synthetic division if you have a trinomial, if your degree is not a 1. It is possible. To be honest, I can't remember how to do it. And the reason I don't remember how to do it is because I never use it, because it's kind of complicated. It's hard. It's not. I don't think it's worth doing. It's going to be more confusing than helpful. But if you're going to be taking college algebra sometime, you're going to be doing this thing called finding zeros of a function, a big function, with great big, like x to the 7th type deals. All right? And you're going to be doing a lot of synthetic division to figure them out. So let's get you figuring out how to do synthetic division. So what I'm going to do is I'm going to take this x plus 1, set it equal to 0, and solve for x. All right, so that negative 1 is what I'm after there. So I'm going to put that negative 1 in a box here. And then I'm going to take the coefficients of this other polynomial that I'm trying to divide the divisor into. So just the coefficients though, right? 1, 3, I don't have that x squared term, so I'm going to put a 0 there. And then a negative 5, and then a 4. And now I'm going to draw a horizontal line. Okay? I love synthetic division. It's one of my favorite things to do. So the first thing I'm going to do is just bring down the 1. No change, okay? Just bring it down. Now, and write it down below my line. And now I'm going to take this 1 and multiply it to this negative 1 that I have in the box here. Okay? And I'm going to write that result up here. So I'm going to take a negative 1 times 1. It's a negative 1. Now, I'm going to add down the vertical. So 3 plus a negative 1. 3 plus a negative 1. That's 2. Okay? So what's happening is we're going to multiply across the diagonal up here to get this number, and we're going to add down the vertical to get this bottom number. Okay, so it's going to be an iterative process as I've worked through the rest of this. So I'm going to take my 2 times a negative 1 here, so negative 1 times 2. That's a negative 2, right there. Add down the vertical, so negative 2 plus 0, which is a negative 2. Negative 1 times a negative 2. Sorry, I know I'm standing right in front of the screen. Negative 1 times a negative 2 is a positive 2. I'm going to write right here. And now I'm going to add down the vertical, so negative 5 plus 2 is a negative 3. Okay? And then negative 3 times a negative 1, we'll multiply those guys together, is a positive 3. And then finally, 4 plus 3 is 7. All right, let's check out some parallels here. See this 1? See this little 1 in front of my x cubed there? Ooh. See this 2? See this 2 in front of my x squared there? Ooh. See this negative 2? See this negative 2 in front of x here? You know their expression now. Ooh. See this negative 3 and this negative 3? All together now. Ooh. And finally, 7 and this 7. Ooh. Yeah, exactly. So this bottom row here is going to be my result. I just need to make sure to drop my degree down by 1. So if it starts as x to the 4th, I need to drop it down by 1. So it's going to be 1x cubed, or just x cubed, plus 2x squared. We go in descending orders of power now. Minus 2x minus 3 plus 7 over x plus 1. So cool. Just like that. I did this problem pretty slow. It took a while. I'm going to do a couple more using synthetic division, but I'm going to move in pretty darn fast. And that's the next video that I'm going to do here in a second.